Good day everyone, this is Sarel van Grenen aka Mr. VG and I am excited to be here today. Today we are going to start off our grade 12 practice for exams. So we are going to look at first of all identical objects. In other words, objects where repetition could or could not be allowed, but repetition is possible. For instance, I could have 3 nines, and all 3 nines look the same. They are the same, but they're in different positions. The same with word shuffling. So we could have an S that repeats itself 5 or 6 or 7 times. Well, all of those kind of sums we are going to have a look at today. First of all, we are going to start with code questions. So our first example comes from a previous year's exam paper. Now, when I look at the previous year's exam paper, this one specifically, it says we're given the digits 3, 4, 5, 6, 7, 8, and 9. And I'm asking you how many unique 5-digit codes can be formed using the digit above if, first of all, the digits may be repeated. So let's have a look at this question and write down first of all what we know. What we know is there are 7 digits for us to choose from. And in 11.1.1, repetition is allowed. So let's draw up our code. 5 little blocks. In the first block, how many options do I have to choose from? I've got 7. Now, whatever digit I choose may be used again. So in other words, the second block, there's also 7. In the third block, there's 7. In the fourth block, there's 7. Even in the fifth block, there's 7. Now, please remember, when you think back about the theory video, the moment you hear the word and, what must I think of? I must think of multiply. So if I multiply that, I get a nice big 16807. So in total, there's 16,807 options available. If I look at the next one, actually that's 11.1.2. If I look at this next one, it now asks us that it tells us the digits may not be repeated. So if we draw up our code, and you would see that I love drawings, I love visualizing what I'm going to do. In the first block, there's going to be 7. In the second block, there's going to be 6 options. Why? Because I've already chosen one of the digits. I may not use it again. Now there's 6 digits left. Then there's going to be 5 digits left. Then there's going to be 4 digits. And for the last one, there's going to be 3. Again, because we say there's a choice between number 1 and 2 and 3 and 4 and 5, we use multiply, which means our answer is 2,520. Quite a few less than where repetition was allowed. When I move over to question 11.2, I'm going to ask myself this question: how many unique 3-digit codes can be formed using the above digits if digits may be repeated, the code is greater than 400 but less than 600, and the code is divisible by 5? So what I'm going to do step by step is I'm going to first of all draw up my 3-digit code. In the first one, because they say to me the code must be greater than 400 but less than 600, what options I have left is in the first one I could have 4 or 5, which means that I don't have many options there. I actually only have 2. Secondly, I'm going to look at how would the code be divisible by 5? Well, that's up to the last little digit. So at the last little digit, I could have either 0 or I could have 5. So now let's look at the possibilities. In the first one, I have 2 options. In the second one, or in the last one, I also have 2 options. But now we ask ourselves, in that middle little block, how many options are there? And here you've got to be careful. Because they say that repetition is allowed, it means there are 7 options. So how many options are there now in total? Let's multiply. And there's a shocking 28 options that are left. So when you look at codes specifically, the important thing you've always got to do, for me at least, is always draw up how many digits there are. Then we have a look at what is restricting the number of options there are. Then we multiply. Important, do not forget to look at whether repetition is allowed or not. I'm going to move over or move up on to a next little example, which I can definitely expect in this exam. Now, the next example is all about word shuffling. I love these questions. So here is a beautiful question about word shuffling. Say I give you the word statistics. And I start shuffling them around. How many words are possible from this shuffling of this word? First question. Second question. How many words will start and end with the same letter? And then the third question, what is the probability in these shuffled words that the vowels will end up being together? Let's start with question 1. How many words are possible? Let's go and have a look. There are 10 letters, of which there are the S's that repeat itself, the T's that repeat itself, there's 3 of them, and then there's also 2 I's. So I gave you a word with quite a few repetitions. So we're gonna have fun. Let's start. There are 10 options available, so I'm going to do 10 factorial. But now I've got to be careful of the repetitions. Because there are 3 S's, I've got to take away those repetitions. So I'm going to divide first of all by 3 factorial. Then I need to get rid of the T's that repeat itself. So therefore I'm going to also take away 3 factorial there, as well as 2 factorial for the I's that repeat itself. And there I've got the total number of words that are possible. For those of you that are looking for the answer will come a bit later on. You can so long go and write out, and let's see if you get the right answer at the end. Now question 2 is where the fun really starts in this specific question. In this question it says how many words will start and end with the same letter. So I basically have 3 options. Either my shuffled word can start with an S, a T, or an I. But then it also has to end with that same letter. So let me again draw up my first possibilities. I have 10 options. If it starts and ends with an S, then I have 1 option inside the blocks. That maybe went a bit quick for you. There I could have an S and an S. So whether we swap them around doesn't matter. An S is first and an S is last. So there's only 1 option. In the middle, I have 3 T's and 2 I's that repeat itself. So, let's start. If I forget about the ones in cement, the ones at the end, in the middle, I have 8 different letters with a few repetitions. So I've got to take away again the 3 T's that repeat itself, as well as the 2 I's that repeat itself. I hope that you agree with me that this is exactly the same if I start or I end with T's, because there are 3 T's. So the total number of ways, I'm just going to say times by T, because it's going to be that exact same thing, except where there are T's, there's going to be S's. And where there are S's, there's going to be T's. The interesting thing comes in. What happens if I start and end with I's? 10 options again. My first and my last block I put in cement. And in those, again, I put there's one option for our end ones, because again, whether I write I first and last, it doesn't really matter how I write them around. What is important is the middle part, because this middle part, again, is now going to be 8 factorial, because there are 8 options in the middle, but I've got 3 T's and 3 S's that repeat itself. So to get the total number of possibilities, because again it's this or that, it means I'm going to add them together. Let's see if you can get that right answer. Before I end off this video, I promise you I'll show you the right answer. Now when it comes to question 3 is a little bit weird, because it doesn't ask me for the number of ways possible. It asks me for the vowels, the probability of the vowels being together. So what I do when they group things together, I like to put things in boxes. So I'm going to put my A, my I, and my I in a box. And the rest I'm going to see at the back floating. So the C, the T, the S, and the other S. If I look at the box doesn't have a fixed position. So I'm going to see that box as being 1 unit initially. So if I look at that 1 unit together with the rest of the numbers or letters, there's going to be 8 factorial. So there's going to be 8 objects that can float around. But inside those 8 objects, I also have repetition. So the 3 T's and the 3 S's I've got to remove. Please be careful of the following. I need to look inside the box as well. Inside the box, there are 3 different objects, but there are 2 I's that repeat itself, so I need to remove them. So if I want to do the number of ways that the vowels can group together, I've got to take all the objects and multiply them by what's happening inside the box. And that will give me the number of ways that the vowels can be grouped together. If I now want to have a look at the probability that the vowels will be grouped together, I must take that number of vowels and divide them by the total number of words that can be found by shuffling. So I'm going to divide that by the first answer I got. And that, ladies and gents, would give me the probability of the vowels being grouped together. So let's have a look at what the actual answers are. First of all, for number 1, there's 50,400 options available. For number 2, there's going to be 7,840 options available. And lastly, the probability that the vowels will be grouped together is a slim 0.067. Ladies and gents, this is some awesome exam type questions. I encourage you, dig in, delve in with this. Make sure that you understand this, and if you are struggling, never be afraid to ask. This is Mr. VG signing out. Have a wonderful, wonderful rest of your day. Look out for our next video. Remember to subscribe. Cheers.